selecting every other row of that matrix. So I have, so now I have C3, C2, C1, C0. Because I'm skipping one. So now instead of a single shift, I have double shift. And that's downsampling. You see a matrix like this, with shift of 3, that's down by 3. Okay, so downsampling. In a time domain, you can see it right away. And exactly the same thing when you copy this, exact form, regression C, D. D3, D2, D1, D0, D3, D2, D1. L. So what we have done here is, I have written this as CV not D1 apply as a matrix compact, right? So V not D1 as a matrix compact. Okay? Well, L here is a cascade of a complete matrix C, the downsampling operation. I know how to represent L and T. Right? And I can sum this as one big matrix, if I wanted to. Okay? You can think of this as that's a vector right here, right? That's a vector. That's also a vector form. That's a matrix, right? So you have a matrix, a vector V equal to a matrix of vector X, right? So vector V, which is a cascade of V naught V1, right, equal to a matrix compact. That matrix is over here. Right? Now, in this way, it's easy to see. What if I want to orthogonality? What do I need to do? I want to make this matrix orthogonal. Right? If this matrix is orthogonal, I know how to invert them. I just transpose it. Okay? So I want to discuss after the break, okay, how to make this matrix orthogonal. If you can do this, then the invert is just a transpose, very easy. We will skip the inversion and leave that exercise to go home and do it. Okay? So the next topic to do after the break is given this matrix, which depends on the filters. Okay? And this matrix is a Toplick, Bennett Toplick matrix, shifted by 2. How do I make this into orthogonal? You can do that and that. Okay? And that depends on how to do C and D. Take a break. Which means that it is orthogonal with norm, unity norm. Okay? So how do we design, how do we choose C and D such that this matrix is to be orthonormal? How do I make it orthonormal? You want norm of this vector equal to 1, right? Tell me the condition. You want C0 square, C1 square, C2 square, C3 square equal to 1. Right? And these have the same norm as this, and so on. And you want exactly the same thing for D. D0 square, D1, D2, D3 to the 1. So that takes care of the normal part. We normalize the normal one. How do I make it orthogonal? So you have two vectors, okay? How do I make them be orthogonal? Inner product equal to 0, right? If you take inner product of two vectors, what do you get? You have C0, C2, So C1, C3 equal to 0. Okay? So C0, C2, so C1, C3 equal to 0. And the same for D. Yeah, D0, D2, so D1, D3 equal to 0. Now this is the case for a length 4 system. If you have length like 6, so on, then you have an additional condition, right? If you have length 6, you have overlap, one more overlap, so on. So let's stay with this example, and we can generalize, find a generalized form later on for arbitrary lengths, given length. So how do I solve this problem? How do I choose a vector such that they satisfy this four conditions? What do we know about C versus D? What do we know about C and D? Are they similar vector or very different vector? One has to be a low pass, right? Because this captures the fourth approximation, the low pass version of the signal. And this has to capture the details. So one is low pass, one is high pass. Okay? So we know that D and C could be related somehow. If C is low pass, D will be high pass. So tell me if I know C of N, and C is low pass, how many ways can I get a high pass? I'm going to use this bracket the same as this, okay? So interchangeably. How many ways can I make a low pass become high pass? In the time domain. In frequency, how do I make it low pass become high pass? You shift by pi. Okay? Shift by pi, this becomes what? What does it look like? C of minus N. That's it? Minus 1 to the N. Would that work? Would make it high pass, low pass, right? Now, if I plug this into here, see what happens, okay? Erase this D and see whether this choice will work. So now, can I make it to be causal? I want to shift by 3, so make it causal. Okay? So D0, which is right here, equal to C3. D1 equal to minus C2. And I give you C1 minus C0. Okay. This row here is basically the D vector, right? D0, D1, D2, D3 with this substitution. Okay? Oh, is this enough? Sorry. Is this enough to be orthogonal? Are we missing something? We look at this, looking at that. We are not looking at this row, right? So we need to have C0, D0, C1, D1, C2, D2. So I have to have D0, D0, C1, D1, C2, D2, C3, D3 equal to 0. So this